Welcome to Meteorology Matters, everyone. Today we're going to take a look at some pretty big changes going on in the institutions that study weather and climate. And we'll be discussing a really interesting debate about just where climate science stands at this moment.
Yeah, and it's you've brought some really fascinating stuff for us to dig into today. An article about shakeups at the National Oceanic and Atmospheric Administration. I'll just call it NOAA from now on.
Sure.
NOAA. And also a really thought-provoking piece from Nature that takes a close look at how our knowledge about the climate is changing. I think our aim today should be to really break these sources down for our listeners. Pick out the most important takeaways and maybe even find some surprising links between them.
Absolutely. So let's kick things off with the news from NOAA. One of the articles you shared, it's from Axios, talks about NOAA merging its Climate Prediction Center, that's the CPC, with another branch of the organization. And get this, the article cites anonymous sources who say that one of the main reasons for this move is a worry that the CPC, simply because of what it's called, might be targeted for budget cuts.
Oh, wow.
It's kind of alarming, especially when you think about the fact that other federal agencies have actually cut funding for climate research before and even removed climate change data from their websites.
It really does highlight, how shall I put this, the difficult atmosphere surrounding climate-related work within government right now. The idea that just the name Climate Prediction Center could be seen as a liability, well, it's concerning to say the least.
Yeah. The article does say, though, that the CPC is expected to stay a separate center, at least for now, while they work out this integration. And their primary function, monitoring and predicting things like El Nino and La Nina and issuing those seasonal outlooks, it's a pretty big deal.
Yeah. Hugely important.
I mean, that information has a huge impact on so many different sectors, like agriculture and energy. It gives them those critical early warnings about big shifts in weather patterns that are coming down the line. But it's important to remember that the CPC isn't solely focused on tracking human-caused climate change or making those really long-term projections, the ones that go way beyond just a season or two. That responsibility actually falls to other parts of NOAA, like the National Centers for Environmental Information.
Right. It's such a critical distinction to make, too. When we're talking about the CPC, we're mainly talking about the shorter-term cyclical climate patterns that have a pretty big impact on us right now, the long-term trends and the influence of, human activity. That stuff is monitored and analyzed by different groups within NOAA. So if the CPC is perceived as being under threat, it really means our ability to forecast and prepare for things like El Nino and La Nina events, which could lead to widespread drought or flooding. That's what's at stake.
And, speaking of that bigger picture, the Axios article also brings up something interesting. It seems like NOAA's kind of downplaying the public visibility of its climate change-related work. They've paused those monthly media calls that used to focus on global climate monitoring, and they've even changed the names of some of their monthly reports.
Hmm.
And on top of that, there's talk of potential staff cuts within NOAA, which, well, it's understandable that people are worried about that. Plus, there's been discussion, the article says, about the current administration maybe considering privatizing or downsizing the National Weather Service, and experts are concerned that, that could really upset the balance that's already in place, this collaboration between the government, universities, and the private sector when it comes to gathering and sharing all that crucial weather and climate data. And the article also points out that the director of the Weather Prediction Center, the one that focuses on the shorter range forecasts, well, they'll be overseeing the CPC during this whole merger.
Yeah, I think it's definitely something to keep an eye on. I mean, both centers, they both deal with forecasting, but their time horizons and specific areas of expertise are quite different. It does raise questions about how priorities might change and how resources are going to be allocated going forward. And that decreased public profile of climate change work, well, that's a significant development too. I mean, even if the data itself is still accessible, having less public discussion about it, it can easily lead to less public awareness and understanding of these crucial trends and the ongoing research that NOAA is doing.
Absolutely. All right, let's switch gears a bit and turn to that perspective piece in Nature called The Other Climate Crisis. The authors, Tiffany A. Shaw and Bjorn Stevens, they lay out a pretty compelling argument. They say that the main way climate science has been tackling things, they call it the standard approach, is basically hitting a wall. This standard approach, the way they explain it, has been pretty effective in explaining some of those big global climate patterns we've observed. Things like why land areas are warming up faster than the oceans and why the Arctic is warming so rapidly. And they say that this success was based on the idea that there's a clear distinction between large-scale and small-scale weather and climate phenomena. and on applying fundamental laws of physics. It's kind of like that initial broad strokes understanding of how the planet reacts to having more greenhouse gases in the atmosphere.
Yeah, exactly. The standard approach has been the bedrock of a lot of our current understanding, wouldn't you say?
Yeah.
It allowed us to get a grasp on the basic mechanisms driving global climate change and to build models that can actually predict these responses on a large scale. The idea that there was this neat separation between these different scales, well, it kind of simplified what is an incredibly complex system. It made it easier to analyze and predict things at the global level.
Yeah. But here's the thing. Shaw and Stevens argue that as the planet keeps warming, we're starting to see these gaps between what's actually happening out there in the real world and what the standard approach would have predicted. And these discrepancies are particularly noticeable when we zoom in and look at things on a regional level. At the same time, they point out that these new computational methods are giving us different ways to look at these problems, new tools in our toolbox, so to speak. They actually draw a parallel to these turning point moments in other areas of science. When a bunch of unexplained observations eventually start to chip away at the confidence people have in the prevailing theory.
I think that comparison to scientific revolutions in other fields is really, really insightful. It suggests that we might be standing at a pretty important crossroads in climate science. The fact that we're seeing more and more of these regional discrepancies, it's not just a bit of random noise. It could be a sign that there's a fundamental limitation in how we're currently thinking about things.
Yeah. And the nature piece emphasizes that while the standard approach has, for the most part, focused on those big planetary scale dynamics, many of the discrepancies that are building up are actually happening at those smaller regional scales. This might suggest that maybe that assumption that we started with about a clean separation between the big and the small stuff, it might not be holding up so well. Or it could be that there are really important processes happening at smaller scales that our current dominant way of thinking just isn't capturing very well. So while we've got a handle on the global warming trend overall, accurately predicting exactly how that's going to play out in your specific neighborhood is proving to be a lot trickier.
And this is where things start to get really real for people. I mean, if the way large-scale and small-scale climate interact is actually more complicated than we thought, or if there are important regional factors that our global models aren't fully accounting for, well, then our ability to give people accurate and actually useful climate information at the local level, and that's the level where people actually feel the impacts, it's going to be limited.
For sure. So the authors go on to talk about what these potential problems mean for policy. Whether it's a full-blown crisis or just a period of really significant change in the science, they argue that going forward, we need to use the actual climate signals that we're observing out there in the real world to really put those underlying assumptions and processes that drive warming to the test. We need to develop new ideas that can actually be tested and promote a more integrated way of thinking about the climate system. One that can bridge the gaps between the different branches of climate science.
The policy implications are huge, too. I mean, if the level of certainty we have at the regional level isn't as strong as we thought, it's directly going to affect how communities and governments plan for and adapt to the specific ways that climate change is going to hit them. That call for a more rigorous examination of the assumptions we're making in the development of new theories, that's essential for both advancing the science and making our predictions more reliable at those local scales, the scales that matter most to people.
Right. So in essence, what the Nature article is saying is that even though we've come a long way in understanding climate change as this global phenomenon, actually predicting and understanding the changes that happen on a regional level is proving to be a really, really tough challenge. And it might require us to completely rethink how we approach the science. They're basically calling for us to take a more critical look at the very foundation of our current climate models, those basic assumptions. And they're saying we need to put more emphasis on figuring out why there's such a mismatch between what the models are predicting and what we're actually seeing on the ground in different places.
It's a call for a more granular and nuanced understanding, right?
Yeah.
I mean, we all get the big picture. The planet is getting warmer. That's clear. But the specifics of how that warming is playing out in different regions, that's proving to be incredibly complex. And addressing these discrepancies, that's absolutely essential for giving communities and policymakers the kind of localized, actionable information that they need to make informed decisions about the future.
Okay, so just to kind of sum things up here, you've given us two perspectives that are connected but also distinct, right? On the one hand, we have potential changes happening within the institutions in the U.S. that are actually doing the climate research and the forecasting. We've got the merger at NOAA and these broader concerns about, where government efforts on climate are headed. And then on the other hand, we have the Nature article, which is presenting a more fundamental challenge to the very way we scientifically understand climate change, suggesting that the methods we've been relying on might be reaching their limits, especially when it comes to those regional forecasts, which are arguably the most important for people.
And what's really fascinating here is how these two developments could interact, right? I mean, if those established ways of doing climate science really are struggling to accurately explain the changes happening on a regional level, then if we weaken the research capacity or reduce public communication about climate trends, well, that could seriously hold us back from actually addressing these discrepancies and coming up with those innovative new approaches that Shaw and Stevens are calling for in the Nature article.
Right. It's all connected. And it brings up a super important question for everyone listening. How should these potential changes within these institutions and the fact that our scientific understanding is always evolving, how should those things influence how we interpret the climate information that's out there and how we get ourselves ready for the future? The Nature piece encourages us to think critically about, the very basis of those climate predictions. And the news from NOAA really underscores the fact that this incredibly important science is always happening within a dynamic political and administrative context.
It really highlights the need for both continuous progress in climate science itself and having a strong, well-supported system for conducting and communicating that science effectively, and recognizing the limitations and the uncertainties that we have in our current understanding, like the Nature article points out. That's just as important as having the resources and the institutional backing to keep pushing those boundaries of climate knowledge forward.
Couldn't have said it better myself. We hope this conversation today has given you a clearer picture of these important developments. And hey, don't forget to follow meteorologist Rob Jones on Instagram @meteorologist, on TikTok @tvmeteorologist, and on YouTube, just search for Rob Jones Hurricane. You'll also find the Meteorology Matters podcast playlist on YouTube.
And here's a final thought to chew on. If our current climate models, like that Nature article suggested, are having a hard time with regional accuracy, what does that actually mean for how we plan and adapt at the local level? It seems to me it means that we need robust research, open discussions within the scientific community, and maybe an even more nuanced understanding of the uncertainties that come with those climate projections, especially at the scales where we feel the most direct and significant impacts.
Thanks for listening, everybody.
Udala.